next we will be taking one parsing example of this Boolean expression. Suppose we take the example ID or ID and not of ID. Suppose this is the Boolean string that is given, B or ID and not of ID. Okay. Now, as we know that this predictive parsing process, it maintains a stack and the input. So, we will be writing it like this. So, there is a stack part, okay. There will be the input as it is there, and then the corresponding action part. Okay. So, initially stack top will contain the start symbol of the grammar B, and the input will be the whole string ID or ID and not ID. This whole thing will be there in the input. Now, we have to see what was the rule for BID. So, if you look into this grammar, this table, it says BID says you have to go by B producing TB dash by this rule. Okay. So, by B going by B producing TB dash, so it says parse B producing TB dash, and they will be put into the stack. So, B is popped out from the stack, and the stack will now contain B dash and T, and input remains unaltered, same as this one. Now, I have to see what is TID. So, TID is telling go by T producing FT dash. Okay. So, it will be so it says that parse by T producing FT dash. So, this T is going out of the stack. Now, the stack will have B dash, T dash and F. Input remains unchanged. So, B dash, T dash, F. Now, F, now stack top is F, and the input symbol is ID. Okay. So, FID, you see FID says that you go by F producing ID. So, it says that you go by F producing ID, and as a result it will be B dash, T dash, ID, this remains same, and then this. So, these two IDs will now match, this ID and this ID will match. So, naturally the corresponding action is advance input pointer. So, now the situation that we have is B dash, T dash on the stack and or ID. So, there is a dollar at the end, input is assumed to be ended by a dollar and not ID and dollar. So, that is the situation. Now, I have to see what is T dash or. So, T dash or is T dash producing epsilon. So, it says that the corresponding thing is T dash producing epsilon. So, T dash will go out of the stack. So, now the stack will become B dash and input will be like this only. Now, B dash or. So, B dash or is telling me go by B dash producing or T B dash. So, it says the action is B dash producing or T B dash. So, they will be put into the stack. So, this B dash goes out and this B dash comes in. So, B dash T or input remains same. So, now these two ORs match. So, we advance the input, advance input. So, this OR goes out. Now, the stack contains B dash T and this has got ID, input has got ID and not ID dollar, fine. Now, T and ID. So, T and ID, you see T and ID says go by T producing FT dash, this rule. So, it says go by T producing FT dash. So, this T goes out of the stack and T dash and F, they are put into the stack, input remains unchanged. Now, FID we have seen previously that it will tell me to go by this rule F producing ID. So, F will be popped out from the stack and this ID will come in, input will remain unchanged. Now, these two IDs, these two inputs will these two IDs will match. So, the action will be advance input, it will be advance input. So, this stack will become B dash T dash and the input will now have AND, NOT, ID, dollar. Now, I have got T dash AND. Now, T dash AND, it says it go by T dash producing AND F T dash. So, it says go by T dash producing AND F T dash. So, this T dash is popped out from the stack, then this new T dash F and AND, they are put into the stack, input remains unchanged. So, again these two ANDs match. So, we have to advance input, we have to advance input. So, it becomes B dash T dash F and then this AND is has been consumed. So, it is not ID dollar. Now, F and not says you go by F producing not B. So, it says go by F producing not B. So, this F is taken out from the stack. So, B dash T dash B and not, input is as it is. Now, these two nots will match. So, it will be advancing input, it will be advancing input. So, this will become B dash T dash B and then it says that I have got ID and dollar, fine. Now, B ID, so B ID says that go by B producing T B dash, this rule. So, it says go by B producing T B dash. Now, so this B will be going out. So, the stack will contain B dash T dash B dash T and then this is ID and this is dollar. Now, T ID, so T ID says go by T producing F T dash. Okay. So, it says go by T producing F T dash. So, if we do that, then the stack content will become something like this. This T goes out and this T dash F comes to the stack and this remains, the input remains unchanged. Now, I have got F and ID and F and ID will tell me to go by F producing ID. So, this will be modified to B dash T dash B dash T dash ID, input will be this one. So, ID will match. So, I will be advancing the input, advance the input pointer. So, my new stack will be B dash T dash B dash T dash. Okay. So, this will be the new stack and here the input will be dollar. So, T dash dollar, so T dash dollar says go by T dash producing epsilon. So, it says go by T dash producing epsilon. So, T dash will go out. Now, the stack will be B dash T dash B dash and dollar, and this will this B dash dollar tells me that go by B dash producing epsilon. So, this goes by B dash producing epsilon. So, this B dash goes out. So, I have got B dash T dash and dollar. Now, again T dash dollar will tell me T dash producing epsilon. So, this says you go by T dash producing epsilon. So, T dash will go out. Now, I will have B dash and dollar and here it says B dash dollar says go by B dash producing epsilon. So, go by B dash producing epsilon. So, this B dash goes out. So, stack is now empty. So, this stack is now empty and this has the input pointer is also at dollar. That means, the given string is a valid string. So, by using this predictive parsing method, so we can construct the corresponding parse tree. So, this way given a grammar, so you can first construct the first and follow sets, and from there you will be able to construct the parsing table, and once the parsing table is made, so this parsing process is automated. So, you can whether to check whether a given string belongs to the language or not. So, you can have this parsing algorithm, so which will be run, and then you can find out whether it is input is coming to dollar, entire input is consumed, and the stack is also empty. So, if you can come to that configuration, starting with the configuration that stack has the start symbol in it and the entire input is there with the pointer at the beginning of the string. So, if you can come to that configuration, then you can tell that okay, the string is accepted by the language. So, next we will be looking into a new topic which is known as bottom up parsing. So, bottom up parsing, so this top down parsing that we looked into, so this actually tried to construct the parsing parse tree starting with the start symbol of the grammar, and from there it was trying to go in a top down fashion to derive the final string. So, another approach that we can have is that we can start constructing from the bottom. So, starting with the inputs, so we try to construct from the bottom, and then we can ultimately merge onto or converge onto the start symbol of the grammar. Now, the problem with the top down parsing was that, so you have to predict, like at some point of time looking at the next input symbol. So, if it is LL1 grammar, so looking at the current input symbol only, you have to tell like which rule to follow. That sometimes becomes difficult, and if you try to modify that look ahead, if you want to make it LLK, then the parser will become very complex. So, that way bottom up parsing is in many cases bottom up parsing will be better, because it will be able to construct from the bottom. So, it knows the input string that is there and it tries to construct from there. So, that way many a time you will find that for certain grammars, so you will be able to formulate the bottom up parsing algorithms, but not the top down parsing. So, the parsing table you can construct for bottom up parsing, but not for top down parsing. So, that makes bottom up parsing more powerful than the top down parsing. So, to start with this bottom up parsing strategy, so they construct parse tree for an input string beginning at the leaves, that is at the bottommost level of the parse tree. So, parse tree at the leaf level, it has got only the terminal symbols, that is the given the input string. So, it will start with that bottom level thing and then try to construct the parse tree, and finally reaching the root, so which is supposed to be the start symbol of the grammar. So, if you can do this, so if you can have if you can show that the entire string can be reduced to the start symbol of the grammar, then we say that the string is accepted by the language. So, an example, suppose we have got that expression grammar which is given by this, so E producing E plus T or T, T producing T star F or F, and F producing within bracket E or ID, and we try to see whether ID star ID is a valid string of this language or not. So, we will do it in a bottom up fashion. So, first ID will be replaced by F. Okay. So, we get this part, then this F can be replaced by T. Okay. So, this is we have got T into ID, then this second ID is replaced by F, and then this T into F. So, that part is replaced by F, then T into F is that F is replaced by T, it should be F should be replaced by T here, and there is a step jump at this point. So, ideally this should not be like this. So, this E should give me T and T should give me F, because E cannot give me F. But anyway, so this to make the space less, so it has been shown like that, but this should be ideally like this, E to T to F. So, you see, starting with the input string, so we can construct the entire parse tree and go to the root symbol, the start symbol of the grammar. So, if we can do this thing, then we say that we have got a bottom up parsing strategy for the grammar. So, next so these bottom up parsers, so they are also known as shift reduce parsers. Why this name? Because these parsers, they work on two operations, mainly on two operations. One is called a shift operation, another is called a reduce operation. So, the general idea is to shift some symbols of input to the stack until we can find a situation where a reduction can be applied. So, we go on shifting some input symbols onto the stack, and then try to replace that part, some part of the stack by applying some reduction. And in each reduction step, a specific substring matching the body of a production is replaced by the non-terminal at the left hand side of the production. For example, if I have got a in the stack, if you find that you have got say T star F available in the stack, and in the grammar there is a rule like E producing T star F, then what we do? So, we can replace this part of the stack by the symbol E. So, that is exactly what is said here. So, we have at each, so that is a reduction. So, we reduce some part of the stack by a non-terminal. So, whatever comes on the left hand side of the rule by which we are doing the reduction, so the stack now will now contain that symbol. So, stack top will now contain that symbol, and the portion on the right side, so they will be used to replace the portion of the stack. So, naturally the decisions, the key decisions during bottom up parsing are about when to reduce and which production we should apply for reduction. So, like shifting, so I can just get the next input and shift it into the stack, but I have to take a decision that at some point of time I will apply the reduction operation also, the reduce operation also. So, when to apply this reduce? So, if you are not doing it correctly, then you will be reducing at arbitrary point, so that it will not be able to generate the parse tree even if the string is correct. So, so I have to do it judiciously at which point I do the reduction, and also there may be several rules by which we can do a reduction, okay, for some point of time. So, it may so happen that if I take say topmost 3 symbols, there can be a reduction, and there can be 2 different rules by which we can do that reduction, or if I look into the topmost 5 symbols, so I can do a reduction. So, that way I have to take a decision like which production rule we apply for doing the reduction. And a reduction is a reverse of a step of derivation. So, in a derivation we are going in a top down fashion. So, we are starting with the start symbol, and then we are deriving the sentential forms till we are at the input stream. And in the reduction process, so this is just the reverse. So, we are starting at the input stream and converting some parts of it into non-terminals, and ultimately the entire thing reduces to the start symbol. So, this is just the reverse of the derivation process, and the goal of bottom up parser is to construct a derivation in reverse. Like say the actual derivation is say for this id star id, the derivation is E to T star F to T star id to F to id star id. So, but the bottom up parser, it will do it in this direction. So, it will start with id star id, then it will find this reduction of id to F, then it will find this reduction of F to T, then it will find this reduction of id to F, then it will reduce this T star F by T, and then finally it will reduce this T by E. So, that is the thing. So, it does it in the reverse direction, okay, compared to a top down parsing. There is a concept called handle pruning. So, what is a handle? So, a handle is a substring that matches the body of production and whose reduction represents one step along the reverse of a rightmost derivation. So, for example, if I have got say this particular right sentential from id star id, then this id can be a handle because there is a production rule which says F producing id, and this right hand side matches with this id. So, this id part is a handle. Similarly, this F producing F into id, then this F is a handle because there is a rule which says T producing F. So, this id is also can be a handle because there is a rule like F producing id, but the problem is, so it will give rise to something like f star f, and then it may not be giving us the actual a rightmost derivation. So, handle it is with respect to a string. So, it is not only that it should be the right hand side of some production, but also it should be part of the derivation process. So, it should be part of the rightmost derivation process. Arbitrarily we cannot take. So, if we can identify proper handles, then we will be able to identify the proper derivation in the reverse. So, this rule, so this will be using this LR parsers or this bottom up parsers. So, they will be using this handle pruning strategy. Okay, so this is the general philosophy of a stack reduce shift reduce parsing policy. So, we will be using a stack to hold grammar symbols. So, grammar symbols means the symbol, the terminals and non terminals. So, both are grammar symbols. So, we will be having a stack that will hold the grammar symbols, and as a result handle will appear on the top of the stack. So, if we have it like this, so if this is the stack, so it has got the grammar symbols in it. Maybe I have got say A, B, then say some E, S, okay, then so this C, E. So, like that, again another E, like that. Now, you see where this capital number, capital uppercase letters, so they are say non terminals, and the lowercase letters, so they are say terminals. So, this may be say some D, this may be A, like that. So, they are at, so this stack can contain both terminals and non terminals. Now, what can be an handle? Like say this handle, it will always appear on top of the stack. So, I can have a handle which spans over, so these three entries. Okay, so A, B, E. So, if there is a production rules like rule like A, B, E, then we will say that this is matching the handle. So, so initially the stack will contain dollar, and the input will be the entire input string W and dollar. So, initially the stack has got dollar, and this stack has got dollar, and this input, if this is the input string W. So, we will assume that there is a dollar character at the end of it, there is a dollar at the end. So, it the whole parsing routine, it will start with this particular configuration, and then it will be an acceptance, it will go to an acceptance configuration if at the end you find that the stack has got $s in it, and it the input is here, the input pointer is here. Initially input pointer was here, and after this parsing process, so input pointer has come to the end of the string, and the stack contains S followed by dollar. So, if this configuration can be reached, so starting with this configuration by taking actions corresponding to the input symbols that you have in W. So, if you can come to this configuration, then we say that this is this is a valid string, the given string W is a valid string of the language. So, this way this shift reduce parsers will work. The basic actions are, it will sometimes it will shift the next input symbol onto the stack, sometimes it will pop out some entries from the stack and apply a reduction operation on them, the reduce operation on them. So, these two things we will be doing. So, how do you when do you take a shift decision and when do you take a reduce decision? So, that will be depicting the design of the parser and or the parsing policy. So, this is a simple example. So, we have got 4 basic operations. So, we have just now we have talked about shift and reduce. There are 2 more operations, one is accept and another is error. So, accept is the situation where you have reached the configuration where the stack top contains the start symbol of the grammar, and the input is also input pointer is also pointing to dollar. So, that is the accept configuration, and in between. So, if you are in a state where the parser does not know what to do, okay, the parsing table or the parsing policy does not tell clearly like what to do, in that case that is an error operation. So, error operation, so you can have some error message flashed, or you can take some error recovery measure, so that the parser can continue parsing reporting the error. So, let us take the same example, the ID star ID. So, the initial configuration will be like this, the stack will be having only dollar and this ID star ID dollar. So, this will be the input. So, right now we do not know how do we take this shift and reduce decisions, but suppose we know that we can choose, we can make these actions, we can make the actions shift and reduce, and the choice is done in this fashion as it is shown here. So, suppose we take a decision to do a shift, then what will happen, this ID will come to the stack. Now, the stack has got dollar and ID, with ID at the top of the stack, and the input will have star ID dollar. Then somehow we come to a decision that we will be following this reduction rule, reduce by F producing ID. So, this ID will be popped out from the stack, and then this left hand side, that is F. So, it will be pushed into the stack. So, stack now contains dollar F. Then looking at F and star, we take a decision that we will be doing a reduction by T producing F. So, this F is taken out from the stack and T is pushed into the stack. Now, getting T and T at the top of the stack and star at the next input. So, somehow we take a decision that we will shift this star into the stack. So, this star is shifted into the stack, and then this looking into this star and ID, this parser takes a decision that I will do a shift operation. So, this ID is shifted into the stack. Now, ID and dollar, then somehow it takes a decision that I will be following a reduction by F producing ID. So, this ID will be replaced by F. Then this T star, then by F and dollar, looking at F and dollar. So, it will see, it will take a decision that will reduce by T producing T star F. So, ultimately, so this way it proceeds. So, ultimately we are at a configuration where we have got the start symbol E on the top of the stack and dollar at the input pointer. So, at that point we accept the input. Okay. So, that is the corresponding action is accept. So, if there was an error in the expression, then at some point, so we will not be able to have any legal activity. So, at that time, so we will flash that there is an error at this point. So, this can come to an error as quickly as possible, and in fact, this bottom up parsing, one advantage is that, so it can come to these errors very quite fast. But of course, how do you take these decisions? So, that is the question. Okay. So, we will look into that as we proceed through the discussions. Now, handle will appear on top of the stack, like say this y z. So, this is the input. So, this y, so this stack has got this thing, this alpha, beta, gamma. So, this is the stack. Now, it will find that this gamma, so gamma will be replaced by B. So, this gamma will be replaced by B. So, so you see that gamma comes at the top of the stack, and that has been replaced by B. Similarly, we have got this in the next step, this y is shifted. So, this is by. So, this becomes it becomes by, and then this by, this beta by. So, this gives me a handle, and this beta by is replaced by gamma. So, that way it can proceed. Okay. This is just an example how these handles can come at the top of the stack. So, there can be conflicts in the shift reduce parsing, and there are two types of conflict, like one is called shift reduce conflict, another is called reduce conflict. So, shift reduce conflict means looking at the next input symbol and the top of the stack. So, there may be two possible actions. So, we can shift the next input, or we can apply some reduce rule, we can reduce operation following some production rule. And if the grammar is such that we cannot identify a single operation. So, both the operations appears to be valid, the shift and reduce operation, then that is called a shift reduce conflict. Another thing is the reduce conflict. So, here the parser does not know which rule to apply for doing the reduction. So, it finds that there some reduction has to be done, but there may be more than one rule which qualifies for the reduction, that is the right hand side of more than one rule matches with the handle, then which rule to follow. So, that is the reduce conflict. So, typical example is say this one. So, statement producing, suppose we have got this particular rule. So, this is the grammar that we have. Now, in the stack, if we have this situation, if expression then statement, and in the input I have got else part. Now, what to do? So, if we are so one possibility is that so it will lead to if expression then statement else statement type of thing. So, that is this one. So, in that case I should shift this else into the stack. So, that is a shift operation. Other possibility is that this so this itself may be the an if then statement. So, if we may try to reduce we may try to reduce by this rule, statement producing if expression then statement. So, this is a shift reduce conflict on the input symbol else. If the input symbol is else and the stack contains something like this, then it is a shift reduce, it can give rise to a shift reduce conflict. So, we will see how to take care of this as we proceed through the classes, and this is we will see that there are some of them can be handled, some of them can be resolved by taking help of the precedence of the operators, some of them can be handled by modifying the grammar a bit and all that thing. But ultimately when you are designing the parser should not have any conflict. Okay. So, it is the compiler designer's responsibility to do something so that the parser does not face this type of conflicts.